Welcome everyone. We're now on the 5th video series. Today we'll be discussing homework related to the cross product and for the upcoming videos as well. So before we begin, I want to first lay some groundwork on what a valid interpretation of the cross product is, similar to how we gave an interpretation for the dot product. So the cross product for two vectors, let's say u, and we use this multiplication symbol, but it's for vectors. U cross v, well, a few things. The result will always be a vector. Now this is in stark contrast to the dot product where the result was always a scalar. So just remember that. For the cross product of two vectors, you always get another vector out. That's one thing. But what is that vector really, what is that result? That resultant vector you get will be, let's call it R for namesake. R will be perpendicular both to u, this symbol just means perpendicular, I like to use this quite frequently, and as well, R will be perpendicular to v. So the cross product is a really good way of generating a new vector perpendicular to the vectors of whatever your inputs were. So that's its purpose. Now the direction of R is determined by using the right-hand rule. So direction of R is determined via the right hand rule. Okay? And that pretty much lays all the groundwork out for what we're going to be doing. Perfect. Good. So that's a good place to jump off and start now. So let's begin. Question 1. Determine U cross V. Okay, so we're given the vectors as geometric vectors. We're asked to determine U cross V. So let's do both. 1A, U cross V. The formula we can use for this is mod U, mod V, sine of the angle between them when they're tail to tail. That's similar to the dot product. We always still want the vectors tail to tail. And times this other vector, n hat. N hat just represents a unit vector, which is perpendicular to both u and v. That's all it is. So this formula is best used in the case when you have two geometric vectors given and you want to determine the dot product. Sorry, the cross product, not the dot product. It's the cross product between two geometric vectors. So let's carry this out. Enough talking on my end. 60, 80, sine of 55 degrees n hat equals 60 times 80 sine of 55, 3,931.9 n hat. Beautiful. B. We have V, we're determining U cross V, so U cross V, this is equal to U, V, same formula, sine theta n hat. Mod U in this case is 112. Times 128 times sine of 164 degrees n hat. Okay. 112 times 128 sine of 164, 3,951.5, and n hat. So notice both the calculations resulted in a vector, right? Because we have that n hat right here. That's representing the vector, and we have some scalar out front. Okay? Important to note, the cross product will always yield a vector, while the dot product yield always a scalar. Okay? So 2, determine A cross B, B cross A for each pair of vectors. So I'm probably going to do B and D here, actually. B and D. So we're determining A cross B and B cross A. A cross B, B cross A. Write them out separately here. So how you were taught in class was to do it like this. So you have 3, 2, 6, 3. You're starting from the second component, cycling back until you hit that second component again. Similarly for B, so we write 5, 9, -5, 5. Okay? And then we cross, cross, cross. And now, you weren't shown this in class, but I usually like to put a little minus symbol here, just so I know that I'm subtracting. And let's figure this out. So A cross B in this case, so I'm going to do 3 times 9 minus 5 times 2. So the first component is 17. Okay. I'll do it in explicit detail for this first guy, just so you see it. So I'm doing 3 times 9 minus 5 times 2. I don't want to use those symbols. 3 times 9 minus 5 times 2. Okay. Then I'm doing 2 times -5 minus 9 times 6. The third component will be 6 times 5 minus -5 times 3. Beautiful. So then we get, what do we get? Move this down here, I guess. We get, so 3 times 9 minus 5 times 2 is 17. 2 times -5 minus 9 times 6 minus 64. 6 times 5 minus -5 times 3, 45. Okay? Good. It's asking for B cross A as well. Okay. So I'm actually just going to put this here. B cross A will be same deal. 5, 9, -5, 5, 3, 2, 6, 3. So I hope you can understand what I'm doing here. I'm just going to give you the answer now. I'll say it aloud still, so you can at least hear me. So 5 times 2 minus 3 times 9, that results in minus 17. And then 9 times 6 minus 2 times -5, that's 64. And we have -5 times 3 minus 6 times 5, minus 45. You probably will have noticed something, but I'm going to do D first before I tell you what it is. Give you the surprise later. A cross B. Okay, and so what are the vectors? We have, oh, here's some nasty decimals. That's all right. So for A, we have 5.7. Now I'm going to cycle through until I hit 5.7 again. Minus 0.2, 4.3, 5.7. Nice. And then B in this case is minus 4.9, 8.8, minus 4.9, 8.8, 12.3, and then minus 4.9. Okay, carrying out the same calculation. Cross, 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 cross. Oh, let me do that a bit better. You can see more clearly. Cross, 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 cross. Minus symbols to make sure I know I'm subtracting. It's a little detail. Okay, so same deal. Guess I'll do one more example, maybe 5.7, 8.8, minus negative 4.9, negative 0.2. Next component will be negative 0.2 times 12.3 minus 8.8 times 4.3. Okay, and the next component will be 4.3 times minus 4.9 minus 12.3 times 5.7. Beautiful. And then the vector we get doing all that is, so 4.7 times 8.8 minus 4.9. A lot of negatives here floating around. Quite annoying. 49.18. Okay. And then we have, just make sure not to screw up your negatives when doing these questions. Include every single negative you see. Minus 8.8 times 4.3 minus 40.3. Okay. And then we have 4.3 times 4.9 minus 12.3 times 5.7. 91.18. Beautiful. That's the vector we get. Now let's do B cross A. How much space do I have left? Decent amount. Okay, B cross A next. So B cross A, I'm going to be doing minus 4.9, 8.8, 12.3, minus 4.9, 5.7, minus 0.2, 4.3, 5.7, cross, 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 and add your minus symbols. Okay. And then the answer we get, repeating that over again, will be minus 49.18 plus 40.3 and then 91.18. You just check that through. minus. Yep. Okay. So, as you might have noticed in parts B and D, the answers we get for A cross B and B cross A are negative scalar multiples of each other, right? So the difference between these guys is always that of -1. So multiplying by -1. And that's a general property of the cross product itself. So this property we call they're anti-commutative. So it's not exactly commutative, but it's the difference of -1, a multiplication by -1. So that's saying A cross B is not equal to B cross A, but it is equal to minus B cross A. Okay? That's a general property of the cross product. And that's what this exercise was trying to highlight. Okay, moving on. Question 3. For question 3, we're asked, for each pair of vectors, confirm that U cross V is orthogonal to U and V. So I mentioned that in the interpretation of the cross product, but here we're going to explicitly check that that is a true fact. So I'm going to do A and C. It's not dilly-dally. So U cross V. That's what we are doing. Okay, so U, I'm going to write the vector U as -3. Start from the second component, -3, 7, 5, cycling back to the second component, -3, 7, 5, -3. Same thing for V, start from the second component, 6, 2, 6, 2, -1, 6. Beautiful. Cross, 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 cross. Add your minus symbols if you like. I prefer to. And then the vector we get from this calculation will be, so we have -3 times 2 minus 6 times 7 minus 48. Okay? And then we have 7 times -1 minus 2 times 5 minus 17. 5 times 6 minus -1 times -3. 27. Okay? So it's also asking the question that confirm that U cross V is orthogonal to U and V. So a surefire way we know to confirm orthogonality is via the dot product, right? So if the dot product between, so we want to check that U cross V, whatever that is orthogonal to U, and U cross V is orthogonal to V. That's what we want to check. Orthogonal and perpendicular mean the same thing. Okay, but that's the same thing as saying we want to check that -48, -17, 27 dot the vector U, which in this case was 5, -3, 7, 5, -3, 7, that the dot product yields 0. Same thing for V. We want to check that -48, -17, 27 dot -162. That's what V is. That also yields 0. Okay, so let's check. We get -48 times 5 plus negative 17. So component-wise multiplication and then add. Negative 17 times negative 3 plus 27 times 7. And that gives us negative 48 times 5 plus negative 17 times negative 3 plus 27 times 7, and the answer is 0. Similarly, minus 48 times negative 1 plus negative 17 times 6 plus 27 times 2 equals, carrying that out, we get 18 times 6 plus 27 times 2, and we get 0 again. To be expected. To be expected. C. U cross V. Okay, U cross V here. So we have negative 6, 2, 4. So negative 6, 2, 4, negative 6. Negative 6, 2, 4, negative 6. And then 8, negative 3, 6. 8, negative 3, 6. 8, negative 3, 6. And then 8, negative 3, 6. And then 8 again. Okay. Cross, 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 cross. Subtraction symbols. This time we get negative 6 times negative 3 minus 8 times 2. We get 2. 2 times 6 minus negative 3 times 4, 24. Okay. And what do we get next? 4 times 8 minus 6 times negative 6. We get 68. Perfect. That's what U cross V is. The same thing now, we check to see where U cross V. If it's perpendicular to U, well, we want that dot product to equal 0. And if it's perpendicular to V, we also want that dot product to equal 0. And in fact, it will. But let's just confirm that it is true. Okay, so we get 2, 24, 68 dot 2, 24, 68. The dot product really doesn't care which order you dot the vectors in. This is not anti-commutative, but it is in fact commutative. So A dot B is the same as B dot A. Stated simply. So what is U in this case? U is 4, negative 6, 2. And V was 6, 8, negative 3. And let's see what we get. When we do this, we get 2 times 4. I guess I'll write it out. 2 times 4 plus 24 times negative 6 plus 68 times 2. 2 times 6 plus 24 times 8 plus 68 times negative 3. Both should give us 0. 2 times 4 plus plus 68 0 for the first guy. 2 times 6 plus 24 times 8 plus 68 times 3. And you're welcome to check at home whether this calculation is right. Perfect. Okay, final one. In quite squished room, I guess. 4a and b. Determine the area of the parallelogram defined by each pair of vectors. So this is a application-based question. 4a. So 4a, so we have P and Q. So P is, I'll write it here, 638. 638. And Q is 335. And we're asked to determine the area of the parallelogram. So we'll say area of the parallelogram. Oh, the area of the parallelogram constructed by vectors P and Q. Okay, that actually has a very simple formula. That will be the magnitude of the cross product between P and Q. Okay? But what is that, right? So we could do the formula mod P, or I guess absolute value P, absolute value Q, sine of theta. That would be correct without the, so we would do absolute value P, absolute value Q, sine theta, and then you ditch the n hat, right? Because we just want the magnitude. The issue with that is that only works if we have geometric vectors. In this case, we have two Cartesian vectors. So we're going to have to do the cross product in the Cartesian way, then take the modulus at the end, and then we'll figure out the answer. So let's do that. So we have 3, 8, 6. So 3, 8, 6, 3. That's how you would write P down. Start from the second component, cycle back until you hit the second component again. Similarly for Q, we have 3, 5, 3, 3. Okay, cross, 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 cross. So then, oh, and the subtraction symbols. What's the vector we get inside? So P cross Q will be 3 times 5 minus 3 times 8, which is -9. Then it's going to be 8 times 3 minus 8 times 3 minus 5 times 6 minus 6. Six times 3 minus 3 times 3, which is 9. Okay. And then we take the absolute value of this, the magnitude of this, which is going to be -9 squared plus -6 squared plus 9 squared. And so we get, squishing it all down, -9, or 9 squared, square root of 198. Okay. Perfect. Let's do B. So in this case, what's really nice for B, actually, for the case of B, we're given the vectors as geometric vectors. So then the magnitude is really easy given by the simple formula, this one. But we're ditching the n hat, right? We don't need the n hat. So it's going to be u v sine theta. That's about it. Or absolute value u, absolute value v, sine theta. Done. Simple as that. So it's the area of the parallelogram spanned by uv. So area of parallelogram constructed by uv. It's just going to be mod u, absolute value u, absolute value v, sine theta. We're given those guys. It's 43.27. So 43.27. Sine of the angle between them as they lie tail to tail. That's 32 degrees. 43 times 27, sine of 32, 615.23. Okay. And I guess I should put units squared, units squared. Okay. So that concludes the first part of the 7.5 video series. I just want to say a quick word of caution, though, before we end off. A lot of the times when I use the formula for the cross product, I did not write it out explicitly as I did here in this case. That was to save you time, so it's an easy watch on your end. But on the test, you should show as much work as you can possible to get any marks that you might miss if you did not show your work, right? So don't be as lazy as me. I'm just doing it so it's an easy watch for you guys on your end. But yeah, thank you for watching, and I'll see you guys soon. Thank you. Bye.